at this section of the numerical methods, and this one is called the linear interpolation. And the linear interpolation simply it is a way of estimating. It is a way of estimating a value which lies within a given set of values. A given set of values like here, when we are looking at we have a given set of values of x, we have a given set of values of t, then they said find the value of t when x is 12. So 12, x12 lies between 10 and 15. That is, it is within 10 and 15. That's why you will find the x1, x12. So the linear interpolation is just a way of how to locate a value which lies within a given set of values using the method of the gradient. Let us look at this example. We're given the values in the table, we have values of x, or values of t, we are recorded and tabulated. Maybe we are experimental values. Then they say use linear interpolation. We use the method of locating a value which lies within a given set of values. Then find the value of t when x is 12. So we come and say we make an extract. Here. And we have already seen that the value of x12 lies between, these are values of x, it lies between x is equal to 10 and x is equal to 15. So which means we are going to take this extract here. We are going to take the 10 corresponds to 25 as value of t. Then what we want is x12, and it corresponds to some value of t which we don't have. Then the 15, and then it corresponds to 39. So when we have that extract, we can use it to obtain the value of t when x is at 12 using the method of the gradient, that is the change in y over change in x, that is the method of the gradient. So we can start with here comparing. We can compare this set of values and this one that is changing y. It is 39 minus 25 over 39 over 20 minus 25 over changing x, which is 15 minus 10, then equals, you can choose to use this one and this one, or you can choose to use this one and this one, as long as we have included the value of t which we are looking for. So you can choose to use this one and this one. So we shall have the change in which is 39 minus t over 15 minus 12. So this one here, 39 minus 25. Use the calculator here. When you use our calculator and get the whole of this term here, the 39 minus 25 over 15 minus 10, we get 2.8. Then this is 39 minus t over 39 minus t over 3. So when we cross multiply here, the 2.8 times 3. 2.8 equals 39 minus t. So when we bring the t this side, we shall have it as will be now 39 minus 8.4. So 39 plus with the 30.6. So they do not state any units, so we don't state. If you understand, maybe these are meters or degrees or something, but they do not state the units, so we don't state any units. If they understand the units, they will include the units in our calculation, but there are no units, so we don't bother ourselves putting the units. So that is how we can find the value of t when x is 12. Then we also use linear interpolation to get the value of x when t is equal to 45. Value of x when t is equal to 45. Let us try that one. The t, these are values of t, so we look for t45. T45 lies between 39 and 54. So we can locate the value of x which corresponds to t which is 45. So we make our extracts here. Make our extract of the values. So we say that the 45 here lies between 39 and 54. So we are taking value of x 15. Corresponds to our value of x which we don't have. Then goes to 20. Then the 15 corresponds to 34. And the value of t is 45 and 54. That's how we can use the method of, that's how we can get an extract. So we do the same thing using the method of the gradients, changing y over changing x. So we can start with the 54 minus, comparing this pair and this pair, so it is 54 minus 39. Then over changing x, which is 20 minus 15 equals, we can choose to compare this one and this one, to compare this one and this one. So if we choose to compare this one and this one, so it will be changing y, which is 54 over 45, and everything is over changing the x, which is 20 minus x. So when we use the calculator there so we are using, if you use our calculators to compute the whole of this one, 54 minus 39 over 20 minus 15, we come up with the value 3. Then also here, when we use the fourth of our 54 minus 45, we shall have as this one will give us 610, multiply 10 minus 3x equals 9. So if you have to make this one subject, we shall have 3x is equal to 610 minus 9, and 610 minus 9, that one will give us 51, so our 3x is equal to 51. Then our value of x, which corresponds to B51 divided by 3, and our 51 divided by 3. So meaning that when you look at the set of values, the value of x, when you look at this x part here, the value of x which corresponds exactly the 17 lies between 15 and what? 15 and 20. So when the value of t is 45, like as you can see the extract 45 here, we can approximate the value of x which lies within that interval. So the linear interpolation is just a method of estimating the value which lies within a given set of values when we are using the method of the gradients. So we can look at another example of how we can use the linear interpolation. And linear interpolation is just extracting values which lies within a given set of values. Like now here, we have been given a set of values of x, and we're given the function of f of x and say use linear interpolation to find, estimate f of x when x are giving us x. We want us to get the value of f of x, the value of x to the value of f of x. So the value of x is 2.15. And when we look at the values of x, this is 2, this is 3, these are the 2.15 lies within that interval. So we estimate the value of x which lies in that interval, which lies within this interval. So we take the extracts, we look at the 2 corresponds. 2 corresponds to 3.88. We have our value of x which we are looking for. The x which is 2.15 corresponds to some value of y which we don't have. And then here it is 3 and it corresponds to 5.11. 5.11. So that is the extract which you can take. Then we use the method of the gradient. That is the change in y. That is 5.11 minus 3.88 over the change in x, which is 3 minus 2 equals to, we can choose to use this one and this one also, and we have change in y, which is 5.11 minus y over the change in x, which is 3 minus 2.15. So we use change in y is a value of y, then over change in x. So we chose to use this one and that one to get it. So 5.1 and 11 by 3.1, then 3 over 2, then we use this one and this one. That is 5.11 minus y over change in x, which is 3 minus 2.115. Then we use the calculators to get the values there. So if we use our calculator, we use our calculator to do the computation here. And when you look at in the whole of this one here, when we use our calculator to come up with 1.23, then this one is 5.11 minus y. Then this is 3 minus 2.15, which gives us 0.85. So when we cross multiply here, we shall have 5.11 minus y equals, when we multiply this one here, it gives us 1.0455. So since we're interested in getting the value of y, so we make y the subject. And if you have to make the y the subject here, it will be y equals to 5.11 then minus, because this one will be plus, minus 1.0455. Then we now have the value y. When we subtract, it gives us 4.0645. You maximize the number of decimal places for accuracy purposes. Okay, so you can maintain 4 decimal places for accuracy purposes, unless the question has dictated that maybe you round off for 2 decimal places or 3, but 4 decimal places it is accurate. And that is the value of f of x. F of x equals to 4.0645 when x is equal to 2.15. 2.15. Then we can use the next part. The next part of the question is estimate the inverse of x. The inverse of x when f of x. So the inverse of x means that here we are looking for the value of x when we have been given the f of x, which is 10.72. When you look at the values here, 10.72, it lies between 8.41 and 11.94. So meaning that the value lies here. So what we want is to get the corresponding value of x. So we come and get an extract here. Get the extract. And that extract will be, because this value is 10.7, it lies within here. It lies within there. So we take 3 and 4. So we'll have 4 and x, 5. Then 4 corresponds to 8.14. Then here, between here is where between 8.14 and 11.9, that's where our value of 10.72 lies. Then 5 corresponds to 11.94. Then we use the method of the gradients to locate the value of x when the f of x is 10.72. We do the same thing. We use the change in y. So the change in y, we can choose to start with this one here. This is 11.94 minus this one here, which is 8.14 all over change in yx, which is 5 minus 4. So it will be 5 minus 4 equals, choose to use 5, 11, change in y is 11.94 minus 11 minus 10.72, and everything is over, changing the y, x, which is 5 minus x. So we can use the calculator to compute and so what we get there. So this one here, when you compute the whole of this one here, it is giving us 3.8, then this term 11.944 minus that giving us 1.22, then over 5 minus x. So when we cross multiply there, we shall have 19 minus 3.8x is equal to 1.22. So since we're interested in getting the value of x, we take that from the other side. We shall have 3.8x is equal to 19 minus 1.22 minus 1.22. This one here will give us 15.78. 15.78. So get the value of x there. So you have the x will equal to 17.78 divided by 3.8. Which x here gives us 4.6789. We maintain a good number of decimal places for accuracy purposes. And you can clearly see the 4.6789, it lies between the 4 and the 5 when the f of x is 10.72. So that is the method of interpolating or getting the value which lies within a given set of values. So now this one here, it is a linear extrapolation, and the extrapolation, it means you are looking for values which lies outside a given set of values. And values which lies outside a given set of values, that is an extrapolation. Like now here, we are looking at they have given us that a commuting taxi, when it covers 13 kilometers, uses a fuel of 1.2 liters, covers distance, consumes this fuel, covers distance, consumes that fuel. And they say, estimates the fuel consumed when the distance moved is 52 kilometers. Now we realize that the 52 kilometers is outside the given set of values, means that there we extrapolate. And if you extrapolate the extract, if it is beyond the given set of values, means that we are going to, the 52 will be outside there. So which means we take the last two. So we take this one and this one, then the 52, and we take it as our extract. And we use the same method of the gradient. So if it was, for example, it was a distance of 8 kilometers, then which means we will take this first two. We take this one and this one, then we also take the 8 kilometers before. So extrapolation, we look at the outside by estimating a value which lies outside the given set of values. Then the interpolation within. So since we're looking at the kilometers, 52 kilometers outside, so we shall take this last two pairs, then we include the 52 and this corresponding amount of the fuel that it consumes. So there we take our extract here. Extract will be, we are taking 20 corresponds to 2.0 liters. Then we are taking the 30 is corresponding to 2.9 liters. Then we are having the 52, which lies outside here, which is 52, and 52 corresponding to the value of F, which we don't have. Because we want to get the fuel which is consumed. So we still use the same method of the gradient. We change in y, we can choose to use this one and this one first. 30 minus change in y 22.9 minus 2.0 over the change in x, which is 30 minus 20. This one equals, we can choose to use this one and this one. Change in y, it will be this one minus this is f minus 2.9 over the change in x, which is over 52 minus 30. So that is, we still use the method, but when you're extracting, we're looking for a value which lies outside the given set of values. So if we use our calculators there, so if we use the calculators here to manipulate 2.9, we get 0.9, then this is the 30 minus 20, we get 10, then you do 0.9 divided by, so we get 0.09, then we have f minus 2.9, then over, so by 52 minus that we have 40. If we cross multiply, the top line, this one times this, so we shall get 1.98 equals, when we get this one, it is f minus 2.9. So when we say getting the value of f, so when we move this one, this side we shall have f is equal to 2.9 plus 1.98. Then we get the value. We get a value of 4.88 liters of fuel. So we include the units. Which are used there. Because the units were tested, the distance was in kilometers and the fuel was in liters. So after calculating, we included. So we say that taxi, when it covers a distance of 52 kilometers, it will consume a fuel of 4.88 liters. That is how to extrapolate. Look at the value nice outside the interval. Kind of example, we are having that examination. Scaling was done such that the candidate A, who the originally scored 35, gets 50%, and candidate B, with 40, gets 65. They are saying determine the original mark for C, whose new mark is 40. So means that originally students are done in the exams, and the score maybe we are not increasing, then maybe the committee standard is a scale them to improve their performance. So they're saying we have here in our extract here, we shall have the original marks. Then we have the new marks. And the new marks there. So we are having a candidate A, whose original mark was 35, gets 50. Then we have candidate B, whose original mark was 40, gets 65. Then candidate C, whose original mark. Now when you look at these new marks, when you look at the new marks, this is whose new mark is 50, the new mark here is 65, then here the new mark is 40. So when you are marking the new marks, we are starting with the one who is having 40. So here we are having the new mark 40 here, then the new mark for this one here, this is candidate A. No, this is candidate C. Then candidate A, whose new mark here is 50. Then we use original mark of 35. Then we have C here. We have we have B. This is candidate B, whose new mark gets 65 when his original mark was 40. So now what we don't have, it is the original mark of the candidate at C, whose new score becomes 60. When you look at that one there, you can use the methods of the extrapolation to get, because we have all these ones. We have these ones. We have the 35 and the 40, the 50, so which means that this is an extract. This is an extrapolation, because in the given values, even though the 35, 40, 50, and the 60, the 40 is outside that interval. Outside the 40 is outside the interval. So which means we use an extrapolation. And if we're using an extrapolation, here we are taking this one here, it is very simple. We can still compare. We're using the 65, changing y minus 50 over changing x, which is 40 minus 35. And take now, we can compare also this one and this one. Then we say now changing y, which is 50 minus 40 over changing x, which is 35 minus x. 35 minus x. So the whole of this one here. So if we use our calculators here, when we use our calculators here, we're having the whole of this one. This is 15 divided by 5, we have 3 here. This one here, 10 minus 4, we're having 10. Then this is 35 minus x. Then when we cross multiply there, this are interested in getting the value of x there. When we multiply, we have 105 minus 3x equals, the side we are having only 10. Only 10 side. So if we move that on the other side, we shall have 3x equals to 105 minus 10. 105 minus 10. Then that one will have x is equal to 3x is equal to 95. So x is equal to 95 over 3. Then our value of x becomes 126. But approximate that because these are marks. So this one here, when you divide this, we're dealing with the exact numbers there in percentages. So the x here can be approximated to 32%. Approximately 32%. So that is what the student obtained earlier, cited when they scale that student can go to 40. That's how we use the extrapolation tool. So we can have this other example, or we have been given an extract of, we have the sec of the angle x in degrees. So we are having x is equal to 60, then this is the x and is 60 degrees and 0 seconds. This is 60 degrees and 2 seconds. This is the 60 degrees and 24 seconds. But for us, we are not interested in them. For us, we are being given a tabulated values of the seconds. So we are going to focus on the seconds. So we are being given use the linear extrapolation to find the set 60 and 48 seconds. So when you look at our table of extract, we are having the seconds start from 0 seconds, 12 seconds, 24 seconds, and 6 seconds. So we realize that the 48 second is outside the interval. So that is an extrapolation because we're going to estimate a value which is not within the given set of values. Because the given set of values lies from 0 up to 36 seconds. But we want us to get this one here, the 60, we know because it is already there. So only concentrate on the part of the minutes, 48 minutes. So instead of 8 minutes, then the 48 minutes lies outside the interval. So that is an extrapolation, estimating the value which lies outside the interval. So we take the last two pairs. When we are getting our extract here, we shall have this 124 minutes corresponds to 2.0245. Then we take the 36 minutes corresponds to 2.0498. Then what we want us to get is the 48 minutes. And 48 minutes lies outside. And that one is the third 48. And what we don't want is now the value of y here. So we can use those values to get it, because that is an extrapolation. The value for the 8 is lying outside. So to get the sine 60 minutes and 60 degrees and 48 minutes, we use the method of the gradient, changing y over changing x. You can start with this 2 and we start by changing y. 2.0498 minus 2.0245 over subtract 36 minus 24. And this one gives us, we can now use also this one and this one, changing y, we can have y minus 2.0498 in x, which is 48 minus 36. So we use the calculator. See our calculators here. When you press the calculator, you will come up with the whole of this term here. It is giving us 0.00221. Maximize the number of decimal places for accuracy purposes. So on this side we are having y minus 2.0498 over. This one is giving us 12. So when we cross multiply, since we're interested in getting the y minus 2.0498, you got the order. So y equals 0.053. You see, if we cross multiply here, the cross multiply will take the square of this side, we shall have the 0.0211 times 12, then it now comes up to 0.0253 when we multiply these two. So when we make the y the subject, because we're interested in getting the value of y here, so when we use the value of y, it gives us 2.0751 when we use our calculators. So that one means that the sec of 60 degrees and 48 seconds is equal to 2.0751. And when we look at the values in the extract, this is 2.0409, then the 48 corresponds to 2.07. So the values were increasing in that along the positive direction of the x-axis. So when we try to look at our value, it follows the suits.